Hello, welcome back. This one is for my geometry students. One of the things that I am asked for help with the most is proofwriting. Everyone is scared of proofwriting, and I get it because every proof is different. And even within a same set of givens and the same thing you're asked to prove, you can get there multiple different ways. So it's sometimes hard to know if you've done it correctly and if you've done it thoroughly. So great, let's start a series on proofwriting. And what I want to say up top is, as you are doing proofwriting, get used to the idea that you will run into some dead ends, and that's okay. It doesn't mean that you failed. It doesn't mean that you will never get to the end of the proof. It just means that you've exhausted one line of thinking and discovered that one will not get you to the end. Great, that's one less thing you have to consider. Okay, so we're going to go ahead. We're going to take a look at a two-column proof. And one of the other things I want you to think about, and you'll hear me say this over and over in this series, is that in proofwriting, you are always toggling back and forth between what they gave you and what they asked you to prove and how those two connect. And so you take what they gave you and you take that as far as you can move forward. Then you go look at what they asked you to prove and you start to sort of move backward from there. Well, if that were true, what would I want to show was true? And then how does that connect to as far as I got with my givens until those things connect? And that's your through line of the proof. Okay, let's go. Okay, so let's take a look here. So first we see our figure. And this is a kind of weird figure, right? It's not sort of your traditional triangle. This is what we call overlapping triangles. Great. And we've got our two columns here, our statement and our reason. And now over here, we have our givens and our what we'd like to prove. So let's examine. So given, segment XY is congruent to segment ZY. So XY, this whole big long guy, is congruent to segment ZY. Okay, and what I like to do is when I have a given, I like to put it into my picture. So that means that that whole segment is congruent to that whole segment. Now I'm choosing to write it like this so I don't get confused about whether I'm saying XP or PY because I'm not sure exactly where to put it. So I'm putting it as the big outside here. There is no right way to do this. You can mark however makes sense to you. This one's easier to mark. XP is congruent to ZQ. So right here is congruent to ZQ. Okay, terrific. And then what I'm asked to prove is that PD is congruent to DQ. All right. So as I said, we go back and forth between what we were given and what we know from what we were given and what we're trying to prove and what we're trying to prove is involved in. That's a question I ask a lot. What is that involved in? So PD and DQ, what are they involved in? Well, they're involved in this quadrilateral here, but we don't have a whole lot of info about this quadrilateral, so that might not be our best place to put energy. They are also involved in these little triangles here. So that could be a place to put our energy. And in fact, we already know one thing about those triangles. We already have a congruent side. So let's kind of keep that in mind as we now start to explore our givens. And you'll notice I haven't put anything in my two-column proof yet because I want to brainstorm a little bit first. I want to see if I can find my way before I start slamming things in here. Okay, so now we explored a little bit about what we're trying to prove and what it's involved in. Now let's look at our givens and what they are involved in. So we have this big long side here. And what is it involved in? Well, one of the things I like to do is kind of trace with my pen and see where do I want to go next. So where I want to go next is turn this corner. And if I go all the way to here, I would have to construct something to get back, which I'll hold in my back pocket. Maybe that's what I need to do. But if instead I go here and I turn my corner here and I go back up here, now there's a triangle that's already constructed. And I know one thing about it, and then I probably know something about this too. Anybody see how? Can you see that if we have the long sides are congruent, and then we have parts of the long sides are congruent, then we also know that the other part would be congruent through subtraction, right? This take away this leaves us with that and that being congruent. And now I've got one side, two sides of a triangle being congruent. And if I've got those two sides, I need either one last side or I need an angle. Well, hey, if I'm looking at this long side here and here, does anybody see that this angle is equal to itself with reflexive? So now I've got this triangle's congruent to this triangle, and by CP/CTC, I get every piece of those triangle is congruent to the corresponding pieces. So now I've got this angle is congruent to this angle, and this angle is congruent to this angle, and this side is congruent to this side. And I'll bet you from all of that, we can wind up proving these things. So now let's start writing some of this stuff out, and we'll connect that last bit. All right, ready? Here we go. Okay, so we're going to start with our givens, right? So we've got xy is congruent to zy, and I would strongly suggest grabbing a piece of paper and doing this along with me. There's nothing like writing something down to get it to stick into your brain. Okay, so there's our given. And then we've got our xp is congruent to zq, and that one was also a given. And then we took those two right then and we went ahead and figured out that py is congruent to qy. Py is congruent to qy, and we knew that from subtraction. Every teacher has their own level of picky, so some people might have wanted you to start off by saying, like, put a little thing in here that says that xy is made up of xp plus py, and that zy is made up of zq plus qy first, and then state that these guys are equal to each other because of subtraction. Each teacher is different, so you'll have to sort of get a sense within your classroom of how in-depth your teacher needs you to go as you're laying these things out. Okay, so now that I've got that, I'm going to put that into my picture, right? And then we established that once we had that, then we had triangle xy. Oh, we knew that that was true because we have side, angle, side. So now we have to say this angle. So angle y is congruent to angle y because of, everybody remember, reflexive property or conjecture. Some teachers call them conjectures. Okay, so now we're ready to state that triangle XYZ is congruent. No, that was wrong. XYQ, excuse me, we're only going that far. XYQ. And now we want to set it up the same way. So that would be ZYP. Right? And that was because of the SAS triangle congruent shortcut. Okay, so now we've got that. So now let's toggle to our givens, or to our what we're trying to prove again. So here's our PD and here's our DQ, and they're part of these triangles, yeah? All right, so we've already got one side of those triangles. So now we could use an angle and another side, or an angle and another angle. Well, does anybody see, right? Here's an angle, here's an angle, here's an angle, there's our side, and same thing, angle, 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 and there's the side that we know. So Does everybody see that from CPCTC, we've got those angles because they are in these initial triangles? Okay, so let's name those. So angle X and angle Z are congruent. And that's from CPCTC. My pen doesn't want to write what my brain is saying. Okay, cool. So let's put those in. So that is congruent to that. Now we just need one more angle. Wouldn't it be lovely if we could prove that this angle was congruent to this angle? Well, let's take a peek. So again, I ask the question, what are these guys sort of part of that we know anything about? So it occurs to me that this angle is part of this 180 degrees. And we know something about this angle because it is also part of that triangle we proved. So we know that that angle right there is congruent. Let's find it in the other triangle. It'd be right here to that angle right there. And if we know these angles are congruent, then what do we know about the supplements of congruent angles? Remember that the supplements of congruent angles are congruent because if this has to add up to 180 and this has to add up to 180 and these guys are the same, then either supplements of congruent angles are congruent or subtraction tells us that these guys also have to be the same. So there it is. Let's lay it out. Okay, so this one we can't just call it angle Q because we've got multiple things here. So we're going to call this that angle XQY is congruent to angle. Okay, let's trace it the same thing. We started at the point ZPY, and that is also because of CPCTC. There, wrote that better. Okay, and now if we know those are true, then we know, I've got some rainbows happening here, that those guys are congruent. So let's name those. So XPD is congruent to ZQD, and that was because of sups of congruent angles. And so now finally, I have that triangle ZQD is congruent to triangle XPD. Let me write that down before I forget those letters. ZQD is congruent to triangle XPD, and that was because of angle, side, angle. And so now I can finally say that I'm going to just make up a new symbol here because I've already used 1, 2, and 3. That side PD is congruent to side DQ from our old friend CPCTC. And there is our 2-column proof using overlapping triangles and toggling back and forth between what we were given, what we were trying to prove, and what each of those pieces of information are sort of involved in. This information was involved in these 2 overlapping triangles, and our overlapping triangles had that same reflexive angle. Those triangles gave us pieces from CPCTC of stuff that was involved in the triangles that what we were trying to prove were part of. And when we put all of that information together, we could prove that these 2 triangles were congruent, which then let us show that those 2 sides were congruent. Okay, so that was our first exploration of working a 2-column proof and how to toggle back and forth between what we were given and what we were looking for. Yeah? Okay, do it again. Pause the video, see if you can name what to do next before I do, right? Get interactive with this. And then click the link for the next video in the series. All right, and as always, keep mathing.